For page 35, you're going to fold this factoring flow chart after we're done with it. Some of the things on here for factoring are going to be very similar to when we were working with quadratic functions. And so some of it is going to be for higher polynomials as well. So some of the methods are going to be the same. And then a couple of them will be a little bit different. So for this factoring flow chart, it says here that if you have your original problem, the first thing that you do, regardless of what kind of polynomial you have, whether it's a binomial with 2 terms, a trinomial with 3 terms, or a polynomial with 4 or more terms, you're going to start with factoring out the GCF. So we've seen that already, and I've actually told you this as well, that you always start out with a GCF. So here's a polynomial. The degree is 3, and so I want to factor this polynomial. So I'm going to start with the GCF, which in this case is going to be 3x. And so when I take out that GCF, I'm going to pull out the 3x on the outside. And so now I have x squared plus 4x minus 12. Because this is a degree of 3, there is a possibility that I could be able to factor this again. And so that's what it says, factor more with what's left inside. Sometimes you can, sometimes you can't. So this actually now turns into a trinomial. And we've learned techniques for this, things like the cross method, the A times C method, unfoiling, so forth. So technically it would fall under a possibility like this where it says 3 terms. And so we're in this term right here where there's no number in front of x squared, which technically it would be 1. And so we would factor this by using whatever method that you've chosen to factor with. And so in this case, whichever you choose, this would become 2 sets of parentheses. X plus 6 would be in the first one, and then x minus 2 would be in the second one. So once you factor this completely, you're going to have 3 separate pieces. 3x is one of the factors. X plus 6 is a second factor, and then x minus 2 is a third factor. If it doesn't have a GCF, then you'll look under to see which of these categories that it falls under. So then, for example, if there's 2 terms, we have 2 things that could possibly happen. We have either a difference of squares that we've already learned, which says a squared minus b squared. Oh, that's the only one that we learned. I'm sorry. And so this is going to turn into a plus b, a minus b. So we've got 2 examples here. Go ahead and pause the video at this point to see if you can factor it yourself. So for x squared minus 9, my a would be x and my b would be 9. I'm sorry, my b would be 3. And so when I go to factor that, it'd be x plus 3, x minus 3 in parentheses. The second one, 25x to the 4th minus 81y to the 4th. Notice this is going to be a higher polynomial. This one is actually going to be a degree of 4. In this case, my a is 5x squared and my b is 9y squared. So even though this doesn't have a square on it, it's still considered a difference of squares. And so when I go to factor this, it's going to be 5x squared plus 9y squared for a plus b, and 5x squared minus 9y squared for a minus b. I can't factor either one of these any more than this, so you would leave it just like this. We'll come back to the sum and difference of cubes in just a moment. We're going to continue up here at the top. These are the ones that we still know how to do from a previous unit. If you have a trinomial, you either have a equal to 1, where it says here no number in front of x squared. There's actually a 1 here. And then if there's a number in front of x squared, that would be with the a sitting here. Same thing when we were working with quadratics. You'll notice that these are all problems that we've already learned how to do. So pause the video at this point and go ahead and do these 4 examples. And then you can check your answer as soon as you're done. So this is what you'll get for each of these. And so, again, nothing here is new. This is what we would have already learned. So we'll go ahead and continue to the one where a would not be equal to 1. In this case, it's going to show it for whenever you do the a times c method, but if you choose not to do it that way, that's also fine. So go ahead and pause the video at this point. Factor it yourself, either using the a times c method or whatever else you've chosen to factor with. And so when you do that, you end up with this as your final answer. So with your a times c method, these are your results. You've got negative 24 that you're trying to find factors of, and those 2 factors would be positive 3 and negative 8 that should give you that negative 5. You split up the middle term using those 2 new factors. So we've got 2x squared plus 3x minus 8x minus 12. And then you'll take out a GCF on both of the pairs. So this is going to be factored by grouping. So here's the GCF of the first pair, here's the GCF of the second pair, and then you would factor out that GCF again. Okay? And in this last one, if you have 4 terms, you can factor by grouping. This works very similarly like the A times C method here. So here I have a polynomial of degree 3. There's 4 terms here. And so you would have learned in Algebra 1 how to do factor by grouping. You do it by pairs. So the first 2, you figure out what their GCF is, and then the last 2. So in the first 2, the GCF is going to be x, and then the last 2, the GCF is going to be 5. So when I pull out those GCFs, you end up with x squared, parenthesis, oh, I think I may have said x. I apologize if I said x. It's x squared for the first 2. I'm sorry about that. It'll be x squared, parenthesis, x minus 2, plus 5, parenthesis, x minus 2. If these two guys here don't match, then either you did the problem wrong, or you can't factor this by grouping, so you have to try a different method. In this case, they do match, so I'm going to go ahead and pull out that x minus 2. And my final answer is going to be x minus 2 times x squared plus 5. Now, this x squared plus 5 would be a quadratic. I'm not able to factor that any further, so I would go ahead and stop there. If you'd like, go ahead and pause the video now and try this next example and see if you can do it on your own. This is another polynomial of degree 3. It has 4 terms, and so the first 2 terms, I'll pair those up and figure out the GCF, which is 4x squared. The last 2 terms has a GCF of -1, so I'll pull that out as well. When I do that, it'll look like this. Now, since the x plus 8 and the x plus 8 both match, I can GCF out again, and you end up with this as your final answer. Now, if you notice, on this next line, we do have a difference of squares, and sometimes things can be factored again. This is a quadratic, 4x squared minus 1. It's also a difference of squares, so I'm going to go ahead and factor that again. I'm going to use this shortcut, a plus b, a minus b, to do that. And when you do, your final factored form is x plus 8, 2x plus 1, 2x minus 1. Those are your 3 factors. In a box here it says don't forget to always check to see if you can factor more. You definitely want to be able to factor more if you can. You want to turn them into linear terms if possible. If you can't turn them into linear terms, that's fine, but if you can, then you would definitely factor further. Now, this is where it becomes a little bit new, so this is going to be different from where we've learned. Some of it is the same type of method, and then some of it's a little bit different. So you have two new formulas for shortcuts for your sum/difference of cubes. This first one, which is a sum of cubes, is going to be in the form of a cubed plus b cubed. This is the shortcut you would use in order to be able to factor that. It's a plus b times a squared minus ab plus b squared. Difference of cubes is almost similar to a it's very similar to a difference of squares, except notice now it'll be a cubed minus b cubed. If you check the formulas between the sum of cubes and the difference of cubes, are actually very, very similar to each other. The a cubed plus b cubed begins with an a plus b in parentheses. However, the a cubed minus b cubed begins with an a minus b in parentheses. The middle terms are the same with exception of this one right here where one's a minus and one's a plus. So it's still going to be a squared, but then it'll be plus ab plus b squared. Aside from the signs out in front of the middle term here and the first term for the first factor, this is almost the exact same formula. So you've got 2 examples. If you like, go ahead and pause the video now so that you can try them on your own. For the first example, we have x cubed plus 27. This is the same thing as allowing this to be x cubed plus 3 cubed. So a would be x, b would be 3. So if I follow this formula here, we would end up with x plus 3 in parentheses, and then x squared minus 3x plus 9. You could use the a times c method or any other method here to try to factor this further, x squared minus 3x plus 9. You'll find that you can't do it. It's prime, and so this would be your final answer. You couldn't break this down any further. Pause the video again at this point to try the next one. So in this first one, this is the same thing as 2x parentheses all cubed minus 5 cubed. So this time your a is 2x and your b is 5. So for your formula for your factored form would be a minus b, or 2x minus 5. In parentheses, you'll also have 4x squared, which is going to be your a squared, so that's 2x times 2x, plus AB, that's going to be 2x times 5, and then plus b squared, so it's going to be plus 25. Again, you could try the a times c method and continue trying to factor that. When you do that, you'll find that you can't go any further. This is going to be true all the time whenever you're doing a sum or difference of cubes. Once you have that trinomial inside the shortcut, it won't be able to be factored any further. You should try, but it won't be able to. All right, so our next one now is going to be very similar if you compare it to the problem right above it. We have above is x squared plus bx plus c, but down here we have x to the fourth plus bx squared plus c. So notice this first term is the square of the first of one another. The second term, the x is being squared and x is normal in the first one. And the c is going to remain the same. So the same techniques that you use for factoring this when a is equal to 1 is actually the exact same techniques that you would use for this. You could use the a times c method even. The only difference is in the first part of your binomials, the first term here, you're going to have an x squared here instead of a just plain x. But otherwise, the method is going to be the same. So if you want to try to pause this one, if you want to try this one on your own, you can. Go ahead and pause it now. If not, it's not that big of a deal. So when I go to factor this one, I know that I'm going to have two sets of parentheses. I know that I'm going to have x squared and x squared in the first part for my first. And then I need factors of negative 21 that add up to be positive 4x squared. When I do that, I'll get positive 7 and negative 3. So I'll just put those simply in the last two spots for my L. And if you were to FOIL this out, you would get back the original problem, so you know you've done it correctly. At this point, go ahead and pause the video and try the next one. So for this one, we'll start with x squared in each of the first parts of the parts. And then now you need factors of positive 36 that give you negative 13. Well, that'll be negative 9 and negative 4. So you'll just simply put those in the last spots. You can only do this when a is equal to 1. Otherwise, you'd have to use the a times c method to split up that middle term. So the only reason I'm allowed to do this is because a is 1 here. So we have x squared minus 9, parentheses, x squared minus 4. So you'll notice that both of these are difference of squares. So we can actually factor both of those again. And so when you do that, you end up with 4 terms altogether, x plus 3, x minus 3, and x plus 2, x minus 2. Now for this next example down here, again, works the same exact way that this one above would have worked. We have an ax to the fourth instead of ax squared. We have a bx squared instead of bx, and then we still have that same c at the end. But the process for that multiplying a by c and factoring would be the same. So in this case, I'm going to go ahead and multiply a times c. When I do that, I get negative 72. So I need factors of negative 72 that give me positive x squared, and that's going to be negative 8 and positive 9. We'll split up the middle term using those two factors. And so I have 6x to the fourth minus 8x squared plus 9x squared minus 12. You'll factor by grouping on both of those pairs, the first two and the second two. So the GCF of the first pair is going to be 2x squared, and the GCF of the second pair is going to be 3. So when you pull both of those out for your GCF, you'll end up with 2x squared parentheses 3x squared minus 4 plus 3 parentheses 3x squared minus 4. Notice these are the exact same thing, and so now you can pull that out. And so this will be your final answer. You could try factoring both of these. It won't go any further than that, so you would be done at this point. So now the only thing I wanted to make note of at the top here, all of these are in called factored form. They're just a bunch of parentheses being multiplied by each other. So each of your answers are factors of the original polynomial. And I have a note up here that says if it is an equation where you have to be set equal to, and if you have to solve, you would actually get this in standard form where it's set equal to 0 first. You would factor using these same methods that we did, but then you would set each of these parentheses equal to 0, and then you would figure out what x is. So the difference between factoring and solving is in factoring you leave your parentheses and your factors in the final answers. So each of these would be called factors, and so this is the factored form. However, if you want to solve, you set each of those factors equal to 0 and then figure out what x is. And that's it for this page. Go ahead and glue this into page 35, please, and fold it before you glue it.